So Azure Local supports GPU acceleration for VMs, definitely. And we can use something called DDA, Discrete Device Assignment, to assign GPUs to individual VMs. So this is where users have their own personal desktops. Or we can use something called GPU-P to assign parts of a GPU to VMs as well. So this is something that allows us to scale even further with the Azure Virtual Desktop and GPUs, where we're partitioning up, carving up a single GPU to multiple VMs.
Hi everyone, my name is Jayant and welcome to Jayant on Cloud. So today I have Lee Harrison from Accutech, and today we're going to be focusing on Azure Virtual Desktop on Azure Local. So as you know, Azure Virtual Desktop is one of the highly successful services that are available, one of the most popular workloads that run on public Azure today. So we're going to discuss about the AVD use cases where customers need to bring some of those AVD services on premises. And we will see how AVD services can actually run on premises through probably targeted on Azure Local. So without further ado, I just want to give it over to Lee to introduce himself. So Lee, first of all, welcome to Giant on Cloud. And over to you. Just feel free to introduce yourself. What do you do? Your background. I know you've been so popular on LinkedIn. By the way, Lee is also a Microsoft MVP. So super excited to kind of share the same platform with Lee as well. So Lee, over to you.
Thanks, Jay, and thanks for inviting me onto the podcast. My name's Lee Harrison. I'm a principal architect with Accutech. I've been with Accutech for just over 3 years now. And my background is mainly all things Microsoft, particularly around virtualization. So for the last 10 to 15 years, I've been working with designing, deploying Hyper-V clustering solutions of one form or another, all the way back to 2008 R2. That's led me on to what we do in more recent times, which is Azure Local and sometimes Windows Server.
All right, so quickly moving on, GPU, Lee. So It's a very, very interesting topic. Because the reason is I had one of the customers very recently, and they pretty wanted to run some of the graphical end users applications. And their primary requirement was GPU support for AVD. So you want to talk about the story about GPU on AVD on Azure Local?
Sure. So again, I'm going to pivot to some slides.
Sure.
Hopefully that will give a good background on where we are with GPUs and AVD and Azure Local. Okay, just making sure that you can see that, Jay, does that come through? Great stuff. Okay, so Azure Local supports GPU acceleration for VMs, definitely. And we can use something called DDA, Discrete Device Assignment, to assign GPUs to individual VMs. So this is where users have their own personal desktops. Or we can use something called GPU-P to assign parts of a GPU to VMs as well. So this is something that allows us to scale even further with the Azure Virtual Desktop and GPUs, where we're partitioning up, carving up a single GPU to multiple VMs. So when we're talking about GPUs, we're focusing on the NVIDIA range, and Azure Local will support the main kind of A and L series GPUs for GPU partitioning or DDA. And the model obviously determines the number of available partitions and ultimately the memory that's available. The different models come with different memory capabilities. So GPUs are designed for VDI. Obviously, we talk about also use cases at AI and machine learning, which you shouldn't forget, because some customers really do need those, particularly in edge locations as well. But primarily, and certainly for AVD, we're talking about VDI support and GPUs. So when we talk about requirements for DDA, we only support, or Azure Local only supports at the moment, the NVIDIA A2 and A16 for DDA. And what we need to do is discover the GPUs in the host, and we need to download and install mitigation driver. For GPU-P, there's more support for further range of NVIDIA GPUs. Slightly different process where you have to download and install the host driver, but you also have to install the GPU drivers into the guest VMs, which is something a little bit additional to get that working. You need to configure the GPU partition count, which gives you or allows you to carve up GPUs in multiple ways. So you can start with 2 partitions, 4, 6. So you're able to spread or assign partitions to more than one VM and carve up your GPU what's appropriate for your environment. We talk about, again, the supported client OS versions, Windows 10 and 11. And yeah, that's the main support again for Windows client and GPUs. So we're talking about session host desktops again, and mostly pooled desktops. If you're focusing on DDA, discrete device assignment, so again, DDA allows physical GPUs to be assigned directly to VMs, and this bypasses the hypervisor for maximum performance. So when you've got these power users, power hungry users running these, critical kind of workloads like CAD design or whatever, you can give them the best performance by dedicating a GPU just to their session host, their own personal desktop. And this is where you'll get the near native performance due to the direct hardware access, enables you to run advanced workloads, again, simulations, video rendering, AI. We get enhanced GPU resource allocation compared to GPU virtualization. Some limitations can be we can't use GPU over multiple VMs, so it's dedicated. So there's a cost and scale implication there you have to be aware of. Live migration isn't supported at the moment as well with a DDA assigned GPU. I think that's going to change in the future. Requires GPU resources for each VM, again, that need the acceleration, and power and cooling considerations. So most kind of modern servers have good support for GPUs, but some GPUs require additional kind of components in the servers like cooling and what have you. So again, depending on what you need, you need to be aware of that when you're putting the BOM together for your servers.
Fantastic.
If you pivot to partitioning, so GPU partitioning, this again allows you to share a single GPU across multiple virtual machines. And it's achieved by allocating portions of the GPU resources. So we're talking about memory, the VRAM on the GPU itself. So with GPU-P, each VM gets a dedicated fraction of the GPU instead of the entire GPU when comparing it for DDA. And the key features are resource sharing. So again, this is about scale. This is about maximizing your cost efficiency with Azure Virtual Desktop when you're using GPUs, because you can have a couple of GPUs in your one of your servers, one of your Azure local nodes, and you can partition it out to multiple VMs. So, if you only had 2 GPUs and you were using DDA, that's 2 VMs you can apportion, GPUs to. Whereas with GPU-P partitioning, if you had a GPU, 2 GPUs, and they had a partition count of 4, then that's up to 8 VMs you can assign GPU partitions to, or GPU resources to.
About GPU partitions, right? So is this something that we provide guidance to the customers because they may not understand, hey, how many partitions are required? Is it all part of the sizing activity that we do after we do the information gathering from them?
Absolutely, yeah. So us as Architect, that's absolutely one of the key services we would offer, where we would have a look at their existing solution, and then we'd discuss with the customer what their user profiles look like. So we will typically run something like live optics for a couple of weeks on their existing hardware, providing this is a solution they're already familiar with, if they're already using, virtual desktops. Or we can get some metrics from other means, and we can gauge from that, what users, what their requirements are, and then by discussing it with the customers to understand whether they've got low, medium, high power user requirements, we can understand what applications they're using, and again get a feel for what individual user requirements are, and we can size it accordingly, and then come up with the builder materials that has the spec of the host nodes correct with in terms of CPU, memory, but also what their GPU requirements would be.
Yeah, I'm sure this is a complex conversation, especially you don't have any ready-made tools that are available today, especially to size a GPU workload. Things like, for example, AVD. I think it's going to be very, very complex when you sit with a customer, try and understand what's the how many graphical users, because they may have a combination of GPU users and non-GPU users. So you kind of have to do a lot of math to get around it. So this is what you're saying is this is something that Accutech pioneers in doing this.
Absolutely, yeah, and we've also had some successes in particularly where customers are modernizing or updating their infrastructure. We can bring the footprint in their data center in terms of power, cooling, rack density way lower than they've been traditionally running. So we can see really significant savings, not just through using AVD and scaling with things like GPU-P and multi-session desktops, but also reducing the footprint in a data center onto servers that are more powerful and sized according to the work that we do working with customers.
Fantastic. I'm super excited to see some, maybe I'm just jumping the gun here, Lee, but do you have any demos lined up?
Yeah, I've got some AVD session hosts running in my lab. One thing I wanted to call out, if it's okay first, just to finish these slides off, I've got just a couple of visual no problem. I've got some visual representations of what GPU-P partitioning looks like in the lab. I just wanted to show you what it looks like, and this all can be done via PowerShell, but I'm using Windows Admin Center here because it's got a good extension into managing GPUs. And so if we look here, we can see one of my physical Azure Local nodes here has got an NVIDIA A2. Okay, and when we come to the number of partitions, this is what it looks like, where you can actually configure that. So here you can see that with this A2, I can carve it up into 16, 8, 4, 2, or 1 partition, meaning that's how many. That's how the VRAM gets divided and how many virtual machines I can assign it to. Okay, which is really a good flexible piece there, and you can see some examples of that being done. Once you've decided how many partitions you want to carve your GPU into, then it's just a simple case of selecting a virtual machine and allocating or assigning it that particular portion of VRAM.
Fantastic.
Okay, and that's how easy it is. So once your GPUs are installed, you install either the host mitigation driver or the host driver for GPU-P, and then you've installed it into the virtual machine. Then you can just simply use PowerShell or go to Windows Admin Center, and you've assigned your VRAM to your virtual machine, and away you go. In this demonstration, we have an NVIDIA A2 GPU that has been partitioned into 4 partitions, one of which has been attached to the session host on the right-hand side. As you can see, under display adapters on the left-hand side, there's no GPU listed, but on the right-hand side, we have the NVIDIA A2 GPU listed as a valid display adapter. So we're going to use the WebGL web app with the aquarium sample that maxes out the frames per second, and adding more fish stresses the GPU. As you can see on the left-hand side, the frames per second, or FPS, is 4 with 500 fish, and we can see that the CPU is really high, being maxed out. If we compare that to the session host on the right-hand side, the frames per second is 15, which is a lot higher, but the CPU is a lot less because the CPU is being offloaded onto the GPU. And in the background, we can see that the fish are a lot smoother on the right-hand side session host desktop compared to the session host desktop on the left-hand side, which doesn't have a GPU assigned.
So it's really stressing the GPU on the right side, right, instead of the CPU.
Absolutely. And for consistency, again, we can see that with the GPU assigned desktop on the right-hand side, the frames per second remains consistent no matter how much fish you add. So we're up to 25, 30,000 fish, and the FPS is still remaining around 15. And it's just a lot smoother than it is on the left-hand side.
This is amazing. So this just goes to show the really incredible usage of GPUs. Especially I had a customer who was a GPU user, and they were particularly because their end users were GPU users, basically graphical end users, and they immediately could make out the difference.
Absolutely. And for those, CPU intensive applications and graphic based applications, it's a game changer. A normal desktop, a normal kind of office user probably maybe not see too much advantage, and just basic non-GPU enabled desktops work really well. But as soon as we get into the realms of needing that more performance, GPU assignments to session host desktops really does make all of that difference. As you can see here, if we increase and decrease the amount of fish, we can see how much smoother it is on the GPU enabled desktop compared to the non-GPU enabled desktop. And again, that CPU, because it all gets offloaded onto the GPU, then there's less impact on the local processing performance of that session host desktop, and it just makes for an ultimately a lot more smoother processing experience and better user experience, and ultimately users will be able to run their applications to the standard that they require. Another optimization that users can benefit from is RDP Shortpath. By default, the RDP protocol is TCP based, but if Shortpath is available, then the TCP connection drops and enables the fallback to UDP, which makes it a lot faster and less latency connection. As we can see in the connection information on these desktops, the connection is using UDP, which means RDP Shortpath is in play, and we can get less latency round trip and a better performance experience for the users to their session host desktops. I hope I've been able to articulate, the virtues of AVD enough for people that are interested. For me, Microsoft have done a really good job to make it accessible, I think, is my final summary. Once you've got your Azure Local cluster, once you've got your logical network and your image, which again, very easy to do in setup, deploying AVD is really easy. You can go through one workflow and you'll automatically have your session host domain joined and ready to go to serve your users.
Integrate some of the Azure constructs as well from a manageability perspective. That's a very powerful statement as well.
Yeah.
That's awesome. All right. So I think we are probably on time. So, well, Lee, thank you so much for your time. It's been such a pleasure, doing this podcast with you. I learned a lot as well. Yes, I'm sure it's going to help a lot of customers and a lot of viewers who want to kind of very keen to understand the AVD capabilities on Azure Local. So if you did like this podcast, feel free to like, share, and subscribe to my YouTube channel. That's Giant on Cloud. Thanks for watching.
Thank you, Jay.